What if our third interstellar visitor isn't a comet, but a message aimed at Earth? 3I Atlas has just slipped into the solar system, and within hours, the James Webb spots something no comet should show: a steady, internal pulse of light. Not reflected glare, not a gas jet, a heartbeat. Now, picture this: a lunar eclipse over Namibia's remote desert, the sky at maximum darkness. Astrophotographers could point anywhere. They hunt down 3I Atlas, and when it slides into frame, the night answers in a shock of electric green. We've named it 3I Atlas. That's not the same as understanding it. It looks wrong, it moves wrong, its chemistry reads wrong. And new clues hint it may have been watching us longer than we've watched it. Let's start with what those cameras actually captured and what that impossible color might be trying to tell us.
Based on what we know, 3I/Atlas shouldn't be green. Or at least, there's no straightforward natural reason for it to be green right now. The leading idea in the community is that 3I/Atlas is an interstellar comet, broadly similar to other comets we observe. It should carry a bright, fuzzy halo of gas and dust, the Coma, and a broad, fan-like tail. But this one likely formed in a distant star system far across the galaxy, so a little weird was expected. The problem is that 3I/Atlas keeps acting in ways that don't add up.
For instance, comets turning green isn't unusual. Because it's so common, we understand the chemistry. UV light from the sun excites carbon molecules in the Coma. In particular, diatomic carbon, C2, two carbon atoms bonded together, glows green under solar ultraviolet. A normal comet rich in these carbon chains would green up in sunlight. Yet observations made over the summer with practically every major telescope indicate 3I Atlas is poor in those carbon chain molecules. There's little to no C2, yet it is undeniably green. Why? We don't know. Aliens? Maybe they're fond of green bulbs. We do know the Coma around 3I Atlas is loaded with CO2, carbon bonded to oxygen, a very different beast from C2. CO2 will boost brightness, but it won't paint the Coma green. And that much CO2 is weird by itself because it overwhelms the H2O vapor, the opposite of a typical comet, which usually carries far more water than carbon dioxide. That's not the only oddity. The Coma is also rich in metals, especially nickel. Metals in comets aren't shocking, and they can evaporate into the Coma, but that happens when a comet dives close enough to the sun for metal to vaporize. 3I Atlas wasn't close. Nickel was spotted while it was still between Mars and Jupiter. There's no simple reason it should be belching metal, particularly nickel, unless you flirt with the spacecraft idea. Rocket engines are commonly built from high nickel alloys, and hot exhaust can carry nickel along with plenty of CO2. Of course, it's probably not aliens.
There's also the matter of how 3I Atlas is flying through the system, likely unrelated to rockets that probably don't exist. The striking part is how constant its track and speed have been the whole time we've had it under watch. From first detection in early May through October, there's been no meaningful speeding up, slowing down, or turning. That might sound normal, but a real comet shouldn't be that steady. As comets approach the sun, they warm and sublimate, solid ices turning directly into gas, and those jets act like tiny thrusters, nudging the body around. Typical comets change speed and heading depending on which face the sun is roasting. That shove is called non-gravitational acceleration, or NGA, and we usually describe it by how far the path shifts in a day. By every measure, 3I Atlas has been shedding volatiles. A small sunward anti-tail formed early, then evolved into a longer tail pointing away from the sun, classic signatures of active outgassing. And yet, the day-to-day NGA for 3I Atlas has hovered around only 1.5 kilometers per day. Compare that with 2I Borisov, the normal one of the interstellar trio, which wobbled by over 100 kilometers per day, roughly 100 times more than Atlas. Maybe Atlas is bigger and harder to shove. Fair thought.
So take Hale-Bopp, one of the largest comets ever seen. At least comparable to 3I Atlas, probably larger, its path still wandered by more than 10 kilometers of NGA per day, about 10 times Atlas's. And Oumuamua beats them all, with segments shifting by over 1,000 kilometers per day. Even against other interstellar visitors, 3I Atlas is unusually steady, so steady it almost reads as intentional, like something guiding it through the inner system. There's probably a natural explanation, but if, hypothetically, 3I Atlas were a steered craft, it could hold a line and change it. Right now, projections put 3I Atlas on the Sun's far side from Earth as it swings through the inner system. We won't get a close look, and it won't get a close look at us, unless 3I Atlas somehow breaks near the Sun and turns up waiting on our side.
Here's a wild idea that might not be entirely empty. Remember the WOW signal? In 1977, astronomers at Ohio State's Big Ear radio telescope, a giant ear for cosmic oddities, spotted something so striking the analysts circled the data and scribbled "WOW" on the printout. It was an intense, narrow-band radio signal, 72 seconds long, from deep space. It wasn't our gear, it wasn't the Sun or any planet, it came from the general direction of Sagittarius. Two things made it unforgettable. First, the energy required to beam a narrowband transmission across interstellar distances would be immense. If artificial, you'd imagine a civilization tapping stellar-scale power. If natural, some exotic stellar process. Second, hydrogen, the universe's most common atom, emits at a specific radio frequency known as the hydrogen line, 1400 megahertz. The WOW signal? Also at 1400 megahertz. If you wanted to shout a simple "we exist" into the galaxy in a way any advanced culture would recognize, that's the channel you'd choose. In the 5 decades since, nothing quite like it has turned up again.
Here's why that matters now. By reconstructing 3I Atlas's inbound path, astronomers find its origin also points broadly towards Sagittarius, the same patch of sky tied to the WOW detection. That coincidence has sparked a provocative thought. Maybe the WOW signal didn't hail from a faraway star at all. Maybe it came from our new visitor, 3I Atlas, which in 1977 would have been way out on the system's frontier, beyond Pluto's orbit, perhaps pinging us to say it was on the way. It's only a hypothesis, unproven and likely unprovable, but it hasn't been disproved either. And that's the mindset to keep as 3I Atlas reveals itself. Objects like this demand we keep our minds open to the universe's wider possibilities. The truth is out there, and it's on an approach vector. If you found this interesting, please give this video a like. It really helps its promotion. Subscribe to the channel and click the bell to stay up to date with new episodes about 3I, Atlas, and other space mysteries. Share your thoughts on this object in the comments. Hypotheses are welcome. And share the video with your friends. There are even more incredible stories from space to come.